Okay, I thought I would do number 55 and just look at this. This is something you could have done actually back in pre-calculus. Doesn't really even take any calculus here. So we're supposed to sketch the graph of this. So I'll just go ahead and, kind of rough hand a graph here, which you can do. All right, so they give us some kind of guidelines to follow to help us. One thing that we've been talking about is when we have something like this, is taking the limit of it, and we can find, the horizontal asymptote. Really, the horizontal asymptote and the limit are the same thing, right? So if I look at this and I think about the Bobo-Botten eats DC, let me rearrange this function and make it x plus 2 and negative x plus 1. The x's have the same power on the top and the bottom, so this is going to be an eats DC, which means I'm going to have a horizontal asymptote, and my eats DC means divide the coefficients of the x terms. So it's going to be 1 over negative 1, which is negative 1. So we're going to have an asymptote at y equal negative 1. Okay, so I'll draw that in here. Now, if you remember how we can find vertical asymptotes, to find a vertical asymptote, we set the denominator equal to 0. Now, there's such a thing as the holes in the graph, but holes in the graph happens when we have factors that cancel out of the numerator and the denominator, and we don't have anything that's going to cancel out here. So all we got to do is set the denominator equal to 0. I'll just go back to the original 1 minus x denominator. If I set it equal to 0 and I add x to both sides to solve, I'll get x equal 1. That's my vertical asymptote. I'm going to draw that in red too. So that's going to be right here. Now, if we look at x-intercepts, x-intercepts come from setting the numerator equal to 0. So let's set the numerator equal to 0 and we'll find our x-intercepts. There's only going to be one because 2 plus x, set it equal to 0, we get x equal negative 2 as our x-intercept. So that's going to be a point on the graph right here. Okay, so let's kind of see what they've asked us about extrema. Now, extrema, I can actually use calculus for this. If I take the derivative of this function and set it equal to 0, I can find my maximums and my minimums. Now, I'm going to go try to do that down here, but this is going to take the product rule, isn't it? And the product rule says it's the low d high, so the low, which is 1 minus x, times the derivative of the high, which is 1, minus high, which is 2 plus x, derivative of the low, which is minus 1, over low squared. Okay, so let's simplify this. It's 1 minus x. This negative times this negative will make a positive, so it's plus 2 plus x. Okay. The x's are going to cancel out, and I'm going to end up with 3, and on the denominator is just going to be 1 minus x squared. So, are there any maximums or minimums here? Can I set this equal to 0? There is no way to set that equal to 0. So we're not going to be able to find any maximums or minimums with this first derivative. So there's really not much I can do in regards to that. We could just make a table of values. Remember, we can verify this on our graphing calculator just by taking it in. Let's plug in x is 0. I'll make a little table of values. I'll try over here. If x is 0, we get 2 plus 0 is 2 over 1 minus 0 is 1, so 2 over 1 is 2. So we have a point at 0, 2. We're pretty sure what's happening is this, because we can see it's going to be increasing there. Usually with these rational functions, the other branches of them are opposite them, so I'm pretty sure where the other one's going to be is down here. But let's verify that. Let's plug in x is 2. 2 plus 2 is 4 on top. 1 minus 2 on the bottom is negative 1, so it's going to be at 2, we're going to be at negative 4. So at 2, we're at negative 1, 2, 3, 4. Okay, so I should have probably made this thing go more like this. So this part right here, I'll kind of just scribble out. We could try something on, a little bit bigger too. We could try x is 4. 2 plus 4 is 6. 1 minus 4 is negative 3. Oh, that came out nicely. We get 4. 1, 2, 3, 4. Negative 2. So I'll make the dots really big here. It's doing something like this. Okay. So I'm able to sketch this. I can go check the, graphing calculator to see if I've got a pretty decent graph here. And, that's how you're going to do these. So that's how you're working these in this section. Remember, you've got the key posted down at the bottom, so if you get stuck on any of them, scroll down there. You can always check your graphing calculator, but if you just kind of want to know what math they did to come up with their information, that's a good place to go check.